Okay, the first announcement I want to make is that you will be having quizzes. Now that your quizzes have started, you are going to be having a quiz, a multiple choice quiz made up of 10 questions after we finish teaching every topic. In total, we think you will have 15 quizzes by the end of the year. And those quizzes account for 15% of your continuous assessment. So your continuous assessment is made up of quizzes, 15%, your labs, 15%, your tests, 2 tests, each test is 10%. So 15% for the quizzes, another 15% for the labs, then test 1, 10%, test 2, 10%. That brings your total continuous assessment to 50%. So we would like to urge you to take these quizzes very, very seriously. The other thing which has become quite apparent is that some of you have decided to get into your friends' email Moodle accounts, try to attempt the quizzes on your friends' behalf so that you can get an advantage. Some of you did that. And your friends, when you got into their accounts, you did not even bother to try to answer the questions. You just wanted to look at the questions so that you could get a better score. So your friends ended up getting 0 out of 10. If you get found out doing this, and you get found out, you are going to get expelled from the university. So your stay in the university is going to come to a halt very, very quickly. The reason why these people who got into other people's Moodle accounts to attempt the quiz on their behalf, they were able to do this, is because people did not change the password to their Moodle accounts. The passwords to the Moodle accounts for many people is to their computer number. So if someone knows your computer number and the username to your Moodle account is also your computer number, if someone knows your computer number, they are able to access your Moodle account. It was simple as that. So it is your duty to make sure that you change the password to your Moodle account before the next test, before the next quiz. If you do not know how to do that, then you come and ask for help, or you can go to computer center in the library basement, under the library basement there. That's where computer center is located. You can go to computer center and you can ask them how to change your passwords to your Moodle account so that other people do not take your quiz on your behalf. Because if they do that, their only interest is to see the questions. They will not try the quiz on your behalf. When you come to the department, you will not be able to do much. Yes, we'll record the complaint, because if a crime has been committed, like in this case, we need to have a record of what happened, so that when the people who are doing this get found out, then we can read them their crimes. They can get expelled and possibly go to jail. So please, if the password to your Moodle is still your computer number, change it as soon as possible. Are we clear? The next thing is, we do not only have 10 questions when you are attempting a quiz. We have more than 10 questions. So the computers, the university computers, are picking from a list of questions, and each person is being given a different question. So you might receive 10 different questions. Your friend you're next with might receive another 10 different questions, and that's how it works. So you're not receiving the same questions. No. You are receiving a computer when you log in, then you try to do the quiz. It chooses 10 different questions for you to work out on that particular topic. So you answer those 10 questions, your bit is done. You don't have to.
So you said how many quizzes are we writing?
15 quizzes. By my estimate. For each topic, you're going to have a quiz. Okay. And we are going to deliberately add more questions on each topic so that the pool of questions the computer has to choose increases. That way, even if you screenshot the questions to send to your friends, you will receive a different set of questions. Each person is going to receive a different combination of questions for you to answer. So there is no need for you to risk your stay in the university, because when we catch you, which we are going to do, we are going to expel you. After we expel you, we'll send you to jail. So unless you think it's worth it, if you are taking part in this thing which happened yesterday, where people got into other people's accounts to see questions, continue doing that. But the moment we catch you, we are not going to show you any mercy. We're going to make an example of you. I hope that is very clear to everyone. Say, if we catch you or we receive a report that you have been screenshotting questions and distributing them to your friends on WhatsApp so that your friends can have an advantage, you can have an advantage. We find screenshots of you sending these things. We are going to, you're going to be caught. Then some disciplinary action is going to be taken against you. Whether you're going to be suspended or you're going to be expelled, that's up to you. Okay. If you have not changed your password to your Moodle, please do so and change it now before the next quiz happens. Are we clear? Okay, so we're going to start with our next topic, which is motion, description of motion, and we are especially interested in what's known as uniform accelerated motion. Motion is basically movement of things, and a lot of things. Sorry?
Yes, it's cutting a lot.
It's cutting a lot. It means I might have to change my internet. Just a minute before I get started. Just a minute for me to change my internet. Let's see. I try to change the internet. So I will start. Yeah. So this evening we want to talk about something called uniform accelerated motion. This is the kind of motion which we are interested in this particular course, and we want to study this uniform accelerated motion as much as it is very simple and basic, but we want to study this so that we can see how we can predict the movement of objects, and also we can analyze that. So as we proceed with what we want to do, we will slowly come up with the meaning of what this uniform accelerated motion means. To start with, accelerated motion means that the speed or the velocity of an object is changing. So when the speed of an object is changing, this change in speed can be one of two things. It can mean that the speed is increasing or the velocity is increasing, or it can also mean that the speed is reducing. So when the speed is reducing or increasing, then that kind of motion is what is referred to as accelerated motion. If the speed or the velocity remains the same, then there is no acceleration which is happening. Are we clear? So by accelerated motion, what we mean is that the speed or the velocity of this particular object we are looking at is going to change, or will change during the time we are looking at it. Either the speed is going to increase or the speed is going to reduce. Okay. Then how does a uniform come in? The uniform comes in that the only kind of accelerated motion we are interested in is one in which the acceleration is constant. And what does acceleration refer to? Acceleration basically measures how fast the speed or the velocity of an object is changing. That's what acceleration is. It is a measure of how fast the velocity or the speed of an object is changing. So the how fast should be the same. That's what uniform is doing there. When something is uniform, it is the same. It is constant. So in this case, we are looking at accelerated motion where the acceleration is the same or it's constant throughout the time in which we are interested in this particular object. In reality, motion, there is very few kinds of motion where the acceleration is uniform. Most of the motion which we undergo in everyday life is not uniform accelerated motion. Yes, it is accelerated because our speed or the velocity keeps on changing. However, the acceleration is not the same throughout the day. And the other thing we're going to do, how we're going to study this thing, we're going to use two methods. The first method which we're going to look at today is one where we're going to use graphs. So we're going to look at graphs of motion, and we're going to see how those graphs allow us to have a picture view of what kind of motion is happening. The other way to study the motion of an object is by using expressions which look like mathematical equations. These expressions in physics are what we call equations of motion. You have seen these so-called equations of motion, I'm sure, in grade 10. So we're going to show you how you come up with those equations of motion. We do not require you to know how to come up with them. What we need from you is to understand what these equations of motions do and how to use them. So we're going to look at this uniform accelerated motion in two ways. The first way we're going to study uniform accelerated motion is by using graphs. Then the second way is by using what are called equations of motion. The study of the motion of objects without looking at what's causing the object to move is what is referred to as kinematics. So this basically, this whole topic you're going to be looking at for the next maybe 1.5 weeks. This is what's referred to as kinematics. So by the time we're done with this topic, you should be able to define what we mean by speed, displacement, distance, displacement, speed, velocity, and acceleration.
Wow.
These are the terms we use to describe the motion of an object. Okay. The next thing we want you to do is you should be able to describe the motion of an object using a graph. When we give you a graph which is showing the distance an object has moved, or when we give you a graph which is showing you how the velocity of an object is changing with time, you should be able to tell us what's going on. The other thing we want you to be able to do is that you should be able to work out how much displacement or how much distance has been moved by an object by looking at the area under a velocity time graph. By working out the area under a velocity time graph, you should be able to find out how much distance or how much displacement an object has moved. So we're going to see that when we work out the area under this kind of a graph, that area is actually gives us a number which has got units of meters. Okay. The other thing is you being able to determine the acceleration. How fast is the velocity of an object changing? You being able to determine the acceleration of an object from the slope or from the gradient of a velocity time graph. My focus is the other types of graphs, like a displacement time graph, there's a velocity time graph, you have an acceleration time graph, but we are not interested very much, we're not so much interested in a displacement time graph and also in an acceleration time graph. Our interest is in a velocity time graph, because a velocity time graph, as you can see, shows us a lot of things. It shows us how the velocity, which we're going to look at, changes with time. It also allows us to find out how much distance has been moved by working out the area under the graph, and we can also find from a velocity time graph what the acceleration is by finding the gradient of the lines on the velocity time graph. So the first thing we're going to look at is to have a very good description of what distance and displacement are. Distance and displacement are related. Distance is a scalar, displacement is a vector. However, the relationship between these two is that distance and displacement in one form or another refer to an amount of length that has been moved by an object during a certain amount of time. So what we consider to be distance is the length which has been moved by an object. That's the distance. Displacement is distance in a specific direction. So if you run a length of 100 meters without telling us the direction in which you have run, we say that you have covered a distance of 100 meters. The size of length you have covered is 100 meters. We do not have any information about the direction in which you were running. That's what distance is about. Distance only refers to the amount of length which has been covered by an object which was in motion. Displacement, on the other hand, refers to distance in a specific direction. So if you cover a length of 100 meters east or a length of 100 meters west, then you are talking about displacement, because in that case you have information about how much length you have covered and also the direction in which you cover this length. Both displacement and distance are measured in meters. However, one of them has information only about the size of the length which was covered. The other one has information about the size of the length and the direction in which the length was covered. Are we clear on what distance and displacement are? Is it clear? I don't understand why I'm not getting any confirmation. Is it clear on what distance and displacement are?
It's clear, sir.
Okay. The next thing we're going to look at.
It's clear, sir. Yes, it is.
The next thing we're going to look at is something called speed and velocity. Again, these two are related. Okay. Speed, to start with, is a scalar. It only has size. Velocity, on the other hand, is a vector, meaning that velocity has got size and direction. When you talk about speed, you are talking about how fast an object is covering distance. Okay? How fast is the object moving? How many meters is this object covering in a second? Then you're talking about speed. If it covers 2 meters per second, if you walk 1 meter per second, that is your speed. Your speed is 1 meter per second. It means that after every second, we estimate that you cover a distance of 1 meter. Okay? In that case, when you're talking about speed, there is information about how fast you're moving, but there is no information about the direction in which you're moving. Speed does not have information on direction. Are we clear? Speed does not have direction. On the other hand, velocity refers to the speed of an object in a specific direction. That's what velocity is. Velocity refers to the speed of an object in a specific direction. That's velocity. So in the case of a car which is moving at 150 meters per second, if the car is just moving at 150 meters per second, that tells you about how fast the car is moving. It's covering 150 meters in 1 second. That is the speed. If you include the direction in which the car is moving, 150 meters per second east, then you are no longer talking about speed, but you're talking about velocity, which is a vector. Are we clear? Speed is how fast an object is moving. Velocity is speed in a specific direction. Velocity has direction. Is there a question? Velocity has direction. Okay. Now, in our discussion about speed, there are two types of speeds of velocity which you are going to meet. The first one is the speed or the velocity of an object at a specific point in time. Okay? The speed of an object or the velocity of an object which is in motion at a specific point in time, this is what is referred to as instantaneous velocity. Okay? The speed of an object at a specific time. That's what is referred to as instantaneous velocity. This is the kind of speed which the police are interested in. When they book you for overspeeding, say you were overspeeding, it is because at that particular point in time, in that area where you are expected to drive your car at 60 kilometers per hour or at 40 kilometers per hour, but at that particular point in time, you were driving faster than the stipulated speed limit, which is required for every motorist to drive in that particular area. It doesn't matter whether before you came to that area you were crawling or you were driving at 5 meters per second. It doesn't matter. What matters is that at that particular point in time, that was your speed. So the speed of an object at a particular point in time, that is what is referred to as instantaneous speed or instantaneous velocity. In physics, we are interested in this instantaneous speed of velocity, but we are only interested in two kinds of instantaneous speed of velocity. The kind of instantaneous speed of velocity we are interested in is the speed of an object when we start measuring the time. So the moment you switch on you press your stopwatch, you want to measure this. The moment you press your stopwatch, at that particular point in time, what is the speed of the object? So that is an example of instantaneous speed. That instantaneous speed, when you switch on your stopwatch, that is what we refer to as the initial speed or the initial velocity. So we're interested in that. The other one is when you stop your stopwatch. So when you start, we want to know what the speed of an object is. That is what we refer to as initial velocity or initial speed. By the time you stop, after 10 seconds, after 20 seconds, we also want to know what is the speed of the object or what is the velocity of the object. That's what you call the final velocity or the final speed. These are the only two kinds of instantaneous speed or velocity we are interested in this course. It does not mean that during the time you're carrying out the measurement, the object has got no speed. No, it has got different values of instantaneous speed or velocity. But the fact that instantaneous velocity refers to the speed at a specific point in time means that there are so many values of this instantaneous speed. We can't keep track of all of these values. So we restrict ourselves to only what the speed of an object is when we start counting and what the speed of an object is when we finish counting the time. That is the instantaneous speed of velocity. Then what happens to the velocity values during the time we are counting? Do we just throw them away? No, we don't. We try to have a picture of what happened in between using another kind of velocity called average speed or average velocity. Now with average speed or average speed or velocity does not tell you anything about exactly what happened. It is just an approximation of what we think happened, which object was moving faster than the other, because for you to get average speed or velocity, what you need is the total distance which has been traveled divided by the total time it took to travel that distance. That's all you need. Okay, so for average speed, which is denoted by V bar, average speed is equal to the total distance which was covered divided by the total time it took. So if you're coming from town center, you're on a bus coming from town center, coming to drop you at UNZA, we measure the distance from where the bus started to where it dropped off. Then you divide by how much time it took. That is going to give you one value of speed called average speed. That average speed, however, does not mean throughout this time you were moving at that particular average speed. No, it doesn't. It just gives us a picture of which object was moving faster than the other. Average speed does not tell us exactly how an object was moving. Whether when you approach your traffic lights, your speed becomes 0. Maybe there was a police, or then you left the traffic. When you approach a bus stop, your bus has to come to a stop. So at that particular point, the instantaneous speed of your bus is equal to 0 meters per second because it's offloading someone or the conductor wants someone to get on the bus. Okay, so all this information about where the bus stopped and how long it stopped there, who came out of the bus and stuff like is lost when you talk about average speed, because average speed is only concerned about how much distance was covered divided by how much time was taken, so that you have a picture which might not be correct of we think how fast this particular object was moving. Are we clear?
Yes, sir.
Okay, so average speed, of course, since there's total distance covered on top, which is measured in meters, then the time at the bottom, which is measured in seconds, average speed, of course, is measured in meters per second.
Yes, sir.
Yes. There is another kind of velocity, which is average velocity, similar to average speed. Average velocity refers to the total displacement covered divided by the total time taken. The thing about displacement is that displacement depends on where you start and where you end while you're measuring the time. So if you start walking, then you measure the time, then you end at the same point where you started. As much as you have covered distance, the displacement might still be zero. If your start point and your end point are the same, you could have covered distance, but your displacement might be zero. A good example when displacement is equals to zero, when you do a lap, you want to go and exercise. You go to the field, then you run around the field once. Where you started, maybe that's where you left your things, then you run from there, then you go around, then you come and stop there. Yes, you have covered some distance, but unfortunately, your displacement is equals to zero, because displacement is just the straight line distance between your start point and your end point. So if you start at the same point, you end at the same point, your displacement is equals to zero. So sometimes you can have your average speed not being equals to zero, because average speed, as long as you have covered some distance, then you have covered some time, your average speed cannot be equals to 0 meters per second. But for average velocity, it is possible that your average velocity can be equals to 0 meters per second if your start point and your end point are the same. Are we clear?
Yes, sir.
Yes, this is the kind of information which you get asked in a quiz, and it looks very confusing because people don't understand things properly. Okay, so the distinction has to be very, very clear. There is another way to work out what the average velocity is. You can find out the average velocity based on what the initial velocity and the final velocity. When you start counting, you start measuring the time. The moment you start, what is the initial velocity, which is the instantaneous velocity at that particular point? Then when you finish counting, what is the final velocity? So when you add your initial velocity plus your final velocity, then you divide by 2. So initial velocity plus final velocity, then you divide by 2. This gives you your average velocity also. So you've got two ways to work out average velocity. If you have the total distance which was covered, divided by, then you divide that total distance by the total time, that's going to give you the average velocity. If you know what the initial speed was, then you also know what the final speed is. Then you add the initial with the final, then you divide by 2, you also get yourself what we call average velocity. Are we clear? So you've got two ways to work out average velocity. Any questions?
No.
Okay. Here is an example.
I have a question. No questions.
You have a question? The person with the question, please go ahead.
Sir, why is it that displacement comes to 0 and you make a round, like circular movement and end at the same point?
Because
Does it mean that the magnitude is 0?
yeah, the magnitude of the displacement is 0, because displacement refers to straight line distance between 2 points. So if your start point and your end point are the same, the distance between them is 0. The straight line distance. Straight line. Displacement is a straight line thing. Okay?
It's clear, sir.
Yeah.
Yes, sir.
So here we have an example in which we work out the average speed. So an athlete takes 10 seconds to run a distance of 100 meters. I think people have run a 100 meters distance, so people have got a good idea of what 100 meters looks like. The only question I'm not sure of is whether people took 10 seconds to run that distance. Because if you take 10 seconds, you're quite fast. Okay? Calculate the average speed of the athlete during these 10 seconds. We are talking about distance because there is no direction. We don't have any information in which direction this guy was running. Was he running in the east? Was he running towards the west? Was he running towards the Chiranga? Or was he running towards the Matero? We don't know. Okay? So the fact that information about direction in which this person was running is not there forces us to talk about distance. So we know that he ran a distance of 100 meters and it took this athlete 10 seconds to cover this distance. Calculate the average speed of the athlete during this 10 seconds. So the average speed is going to be equal to the total distance covered, which is 100 meters, divided by the total time taken, which is 10 seconds. And that's what we're working out here. So the distance on top, D, divided by the time at the bottom, and that gives us an average speed of 10 meters per second squared. So 10 meters per second. If you look at this 10 meters per second, you might think this athlete in these 10 seconds, for each second, you might think this guy was covering a distance of 10 meters. But we know that no one runs like that. Because when you're running this 100 meters, for those of you who have tried to run this 100 meters, if you haven't, you should try to run a distance of 100 meters. You will notice that when you start off, the first few seconds, you cover less distance. Then eventually you run faster. Then as you approach the 100-meter mark, you reduce. So it's not possible that after each and every second, this person was covering a distance of 10 meters. Is what I'm saying clear? It is not true that this guy covered 10 meters every second, because that's not how people run. You start running slowly, then you increase your speed, then as you reach the end, you slow down. So most of the distance you cover it in the middle. Are we clear?
Yes, sir.
Yeah.
Yes, sir.
So this is one of the disadvantages with average speed. Average speed does not tell you exactly what happened. Okay? Average speed doesn't tell you what happened. How the person ran, whether this person fell or they fell twice as they were running the 100 meters, we don't know. That information is not there. But if we're looking at instantaneous speeds, we could have seen how this person was running. Then we could even say, oh, this person fell here. Oh, this person slowed down here. Maybe they fell or something happened. Or maybe something came out from the ground and scared the person or something like that. Or maybe they dropped their phone or they dropped their wallet. That's why they slowed down here. Okay? But that information is not here when you're looking at this average speed. However, average speed is important for comparing who ran faster than the other one. So if another person ran the same 100 meters, then they covered it in 5 seconds. So it's going to be 100 meters divided by 5 seconds. That's going to give us an average speed of 20 meters per second. So in that case, we would conclude that the guy or the person, whether it's a human or something like that, whose average speed is 20 meters per second, ran faster than the person whose average speed was 10 meters per second. So average speed is not completely useless. It allows us to find out which object was moving faster than the other one. Are we clear? Are we clear?
Yes, sir.
Yes.
Yes, sir.
As much as average speed hides information about what happened, it's too important for certain things, as we are going to see most likely tomorrow. The other quantity we are interested in is something called acceleration. Now, acceleration refers to how fast the speed or the velocity of an object in motion is changing. What we are interested in physics, especially in this course, is something called average acceleration, because your acceleration can keep on changing. In the reality, your acceleration can keep on changing every time. That's not what we want. What we want is an average value of acceleration. And how are we going to do that? We're talking about average because our definition of this acceleration is going to be based on only two things. It's going to be based on the initial velocity and the final velocity. So if it's based on initial velocity and the final velocity, then we can work out something called average acceleration. And what we're hoping for in this course is that this average acceleration remains the same. And how do we define average acceleration? It's a change in the velocity of the speed divided by the time which has been taken. Change in velocity or speed means that there must have been an initial value of the speed of the velocity, and there must be a final value of the speed of the velocity. So for you to work out change, there must be a final value of something you're interested in. There also must be an initial value of something you're interested in. So if the velocity is not changing, then you can't have acceleration. For you to have acceleration, the velocity or the speed has to change. Are we clear? For you to have acceleration, the velocity or your speed needs to change. So we define our average acceleration A as the change in velocity divided by the change in time. This change in velocity is worked out this way: the final velocity or speed minus the initial velocity or speed divided by how much time it has taken to carry out this change in velocity or speed. So we can work out our acceleration as equals to A is equals to V, which is the final velocity, minus U, the initial velocity, divided by time. When you do this, this acceleration is going to give you a measure of how fast the velocity is changing per second. Our hope is that the velocity changes at the same rate. The rate stays the same. So let's see an example of this. A car accelerates from rest to 28 meters per second in 10 seconds. Calculate the average acceleration the car experiences. So in this case, there is time here, the 10 seconds. This 10 seconds tells you that we were measuring time. We had to start measuring from somewhere. So when we started measuring the time, what was the speed of the car? We are told the car started from rest. If something starts from rest, then the velocity of that particular something is 0 meters per second. Then at the end of the 10 seconds, the velocity of the car was 28 meters per second. So this is our final velocity. So we have an initial velocity, U, of 0 meters per second. That's when we started measuring this 10 seconds. Then we have a final velocity, V, of 28 meters per second. This is when we ended the measurement. And the time it took was 10 seconds. This is the kind of time we're interested in physics. In physics, we are not interested in what time you start having your breakfast and what time you finish your breakfast. Say, no, I had my breakfast at 7:30. We're not interested in that. What we are interested in is how long was your breakfast. So if you started your breakfast at 7:30, then you finished your breakfast at 7:45, what we are interested in is the difference between the time you started and the time you finished, which is the 15 minutes. That is what we refer to as time in physics. the duration when something is happening. Okay? The duration when an event is occurring. That is the kind of time we're interested in. When we say 10 seconds, it means that during this 10 seconds, the velocity of this car was changing from 0 to 28 meters per second. So how fast did the velocity change? That is the average acceleration. So the average acceleration, for you to find average acceleration, A is going to be equal to the final velocity minus the initial velocity divided by the time. The final velocity at the end of the 10 seconds was 28 meters per second. Then the initial velocity when we started looking at this thing was 0 meters per second. And how much time did it take to make this change? It was 10 seconds. So 28 meters per second minus 0 meters per second, you end up with 28 meters per second. This is something you're supposed to be aware of, is that when you subtract a final velocity minus the initial velocity, what you end up with is a quantity which still has units of velocity. In this case, it is our 28 meters per second. This 28 meters per second divided by 10 seconds gives us something which looks like this. It gives us 2.8 meters per second squared. This is what we refer to as the acceleration of the car. What does acceleration in reality mean? It means that the velocity of the car was increasing by 2.8 meters per second every second. This is what acceleration means. This 2.8 meters per second squared, this is what it means. It means that the velocity of the car was increasing by 2.8 meters per second every second. What do we mean? Here we have a table on top here. So this table, as you can see, it has got time in seconds here with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for the 10 seconds. So when we just started measuring the time at t equals to 0, the velocity of the car was 0 meters per second. After 1 second, according to this acceleration of 2.8 meters per second squared, this acceleration means that after 1 second, the velocity of the car increased by 2.8 meters per second. So after 1 second, the velocity became 2.8 meters per second. Then after 2 seconds, the velocity of the car increased by another 2.8 meters per second. So after 2 seconds, it became 5.6 meters per second. Then after 3 seconds, the velocity of the car increased by another 2.8 meters per second, and it became 8.4 meters per second. Then after 4 seconds, the velocity of the car increased by another 2.8 meters per second, then it became 11.2. Then after 5 seconds, the velocity of the car increased by another 2.8 seconds, then it became 14 meters per second. Then after 6 seconds, the velocity of the car increased by another 2.8, then it became 16.8. After 7 seconds, the velocity increased by another 2.8 meters per second, it became 19.6. Then after 8 seconds, the velocity increased by another 2.8 and it became 22.4 meters per second. After 9 seconds, the velocity increased by another 2.8 meters per second, then it became 25.2. Then after 10 seconds, the velocity of the car increased by another 2.8 meters per second, then it became 28. These values, the 2.8, 5.6, 8.4, 11.2, 14, 16.8, 19.6, 22.4, 25.2, 28. These are values of velocity at these specific times. These values are what we call instantaneous velocities. The velocity of an object at a specific time. So with this table tells us exactly what we think the velocity of the car was at a specific time. Are we clear? Are we clear on the video cut?
Yes, sir, it did.
Okay, let me share.
Yes, it cut.
Where did it cut? When I was talking about what?
When you were explaining about the values, the increase by acceleration.
Okay. So, I explained how these values increased, how they're like this.
Yes, sir.
Okay.
Yes, it did.
So, these values, the 0 meters per second, the 2.8, the 5.6, the 8.4, the 11.2, the 14, the 16.8, the 19.6, the 22.4, the 25.2. These are values of velocities. These are velocity values at a specific time. Okay? After 1 second, the velocity is 2.8. At 2 seconds, the velocity is 5.6. At 4 seconds, the velocity is 11.2. At 7 seconds, the velocity is 19.6. These are values of velocities at specific times. These are what we refer to as instantaneous velocities. Are we clear? The velocities in this table are what we refer to as
Yes, we're clear.
instantaneous velocities. The velocity of an object in motion at a specific time. When we start measuring the time at 0, this one, the velocity at the beginning, when you start measuring the time, that is what is known as the initial velocity. The velocity when we finish measuring after 10 seconds, that's what is referred to as the final velocity. For us to work out acceleration, what you need is the velocity at the time when you finish measuring, which is the final velocity, the 28 meters per second, and the velocity when you started measuring, which is the 0 meters per second. In between here, the thing about average acceleration is average acceleration gives us one value. With this one value of average acceleration, it allows us to predict what we think happened in between this time, from the 0 to the 10 seconds. This is what we think happened. We think the velocity increased in this manner. Are we clear?
Yes, sir, but I have a question.
Yes, go ahead.
Sir, what is a square second?
A square second.
Yes, sir.
A square second per se. So what is a square second? There is no physical quantity called a square second. When we write 2.8 meters per square second, what it means is that the velocity increases by 2.8 meters per second every second. This is what it means. When you have
We
2.
right to pronounce it per second.
You can pronounce it whichever way you want. Per second, but we us will pronounce it as a square second. Okay, so that's what it means. It means that the velocity is increasing by this amount, 2.8 meters per second, every second. Are we clear?
Yes, sir.
Yeah. So this information which we have here, this information of what the time and also the velocity, the instantaneous velocity, this information, yes, we have put it in a table. However, Betha, can you switch off your microphone? Betha, Felix, Nathan, your microphones. Betha, can you switch off your microphone or we have to remove you from the discussion? Okay. Okay. So this information we have put in this table, yes, it's there in the table, but it doesn't show you exactly what happened. It's even better if you try to present this information on a graph. And that's where our graphical things come in. This same information which we have, we're going to present this same information on a graph which is known as a velocity time graph. And when we do that, this is what it looks like. So this is the kind of graph you have. So on the y-axis, you have your velocity in meters per second, and on your x-axis, you have your time, which is measured in seconds. So you can clearly see how the same information, we had it in a table, now we present that same information on a graph. And you can clearly see a nice dots. And from the way the dots are, you can tell that these dots lie on a straight line. The reason why these dots lie on a straight line is because the velocity is increasing by the same amount. Between this first dot, the first dot here, and the second dot, the increase in velocity is the same. Between this dot and this one, the increase in velocity is the same. Between this one and this one, the increase in velocity per second is the same. Between this and this, so between all these dots, the increase in the velocity per 1 second per second is the same. This is, sorry?
I can't get you, sir, too.
I'm saying that between these dots, which refers to the velocity at a particular time, the increase in velocity is the same. Okay? How fast the velocity is changing between these dots, it's the same. That how fast the velocity is changing, that is what is referred to as acceleration. So our hope is that the acceleration between these dots is the same. When the acceleration is the same, it allows us to predict what the velocity is going to be. It also allows us to predict how much distance an object would have moved. So let's look at this graph. We're going to start with the slope of this graph. We have got so many points. If you choose any points, in this case, in these notes, I chose the point at t equals to at 8 seconds. So I chose this point at 8 seconds, and I also chose this point at 3 seconds. So between these 2 points, the one at 8 seconds and the one at 3 seconds, we work out the slope. When we do that, so the slope or the gradient, so the one at 8 seconds, if you look at your table, at 8 seconds, the velocity of the car is 22.4 meters per second. Then at 3 seconds, the velocity of the car is 8.4 meters per second. Using these values of time and velocity, we can work out the slope of this graph, of this velocity time graph. This velocity time graph. When you work out the slope, so the slope is going to be the change in the velocity here, the change in the velocity divided by how much time it has taken. So that's going to be V8, which is the final point, divided by V3, then T8 divided by T3. When you do this, so your V8 is 22.4 meters per second, then your V3 is 8.4 meters per second, then at the bottom your T8 is 8 seconds, then your T3 is 3 seconds. So at the top here, on the top here, you end up with 14 meters per second, and then at the bottom you end up with 5 seconds. 14 meters per second divided by 5 seconds gives you this 2.8 meters per second squared. This 2.8 meters per second squared, which is the slope of our graph, of this graph. Yeah, the network has just cut up soon. Just a minute. Okay. Yeah. Are you able to see?
Yes, sir.
Yes. So
Yes, sir.
that 2.8 meters per second, which is the slope. If you look at this 2.8 meters per second, this 2.8 meters per second slope has got units of acceleration. So the first thing here is that when you have this kind of a graph, when you have a velocity time graph, the velocity on the y-axis and the time on the x-axis, when you work out the slope of this graph, it will always give you a physical quantity which has got units of acceleration. The reason why it has got units of acceleration is because the slope, as you can see in this example, which is 2.8 meters per second, is equal to the acceleration of an object. Here, this 2.8 meters per second. So when you have a velocity time graph, then you work out the slope. That slope is equals to the acceleration of an object. That is one of the reasons why we love a velocity time graph, because a velocity time graph shows us what is the velocity of this object at each and every point. After every second, it tells us, oh, this is the velocity. So we see exactly what the velocity is at each and every point. But the other thing we can do with the velocity time graph is that when we work out the slope of the line, then that gives us the acceleration. So we actually get to know how fast the velocity is changing. Are we clear? When you work out the slope of velocity time graph, it tells you how fast the velocity is changing. That's one of the things we can do with the velocity time graph. The last thing we can do is when we work out the area under the velocity time graph. From here, we go up like that. So that is your graph. Then this area under this graph. When we work out this area under this graph, as you can see, it looks like a triangle. So if it looks like a triangle, our base is going to be down here. That is going to be the time. And the base is going to have a length of 10 seconds. The height is going to be this side. So it starts from 0 meters per second. It goes all the way up to 28 meters per second. So with this base and height, we can find out what the area is under this graph. When we do that, which is what we're trying to do here, area of a triangle is equal to half times base times height. In this case, the base is 10 seconds and the height is 28 meters per second. When we do this, we work out the area of this triangle. It's going to be half times 10 seconds times 28 meters per second. When you do this, you get something which looks like 140 meters. This 140 meters can only be one of two things. It's either the distance which has been moved by the object or the displacement. In our case, because we are looking at a velocity time graph, this 140 meters per second is the displacement which has been moved by the car. So, the area under a velocity time graph gives you the displacement. Are we clear? The slope of a velocity time graph gives you the acceleration. The area under the graph gives you the displacement. If you are interested, now that we know that the area under a graph gives you the displacement, if you are interested in finding out how much distance was covered between 4 seconds and 8 seconds, so you come here, 4 seconds, it's this area. Up to that point, then you go all the way up to that point, then you come down this way. So this area is the area which refers to the distance which was moved by the car in between 4 seconds and 8 seconds. Looking at this shape, this looks like a trapezium. So if you work out the area of this trapezium, that area of the trapezium is going to give you how much distance was covered by the car between 4 seconds and 8 seconds. You can do all sorts of things. From this same graph, because the area under the graph gives you the distance, from this same velocity time graph, you can actually come up with, by working out the areas of the triangles, you can come up with the distances, how much distance was moved after 1 second, by working out the area, how much distance was moved after 2 seconds, how much distance after 3 seconds, how much distance after 4 seconds, how much distance after 5 seconds, how much distance after 6 seconds, how much distance was covered after 7 seconds, how much distance was covered after 8 seconds, how much distance was covered after 9 seconds, how much distance was covered after 10 seconds. How do you do that? Let's start with the distance covered after 1 second. So it's going to be this area. From this point, this triangle up to there, you come down like this. So this small triangle here, the area under this small triangle is going to be the distance covered after 1 second. The area under this triangle here is going to be the distance covered after 2 seconds. This one. That will be the distance covered after 2 seconds. Then from there up to there, that's going to be the distance, this triangle, small triangle, is going to be the distance covered after 3 seconds. Then from here, all the way up to there, that's going to be the distance covered after 4 seconds. Then from there up to there, that's going to be the distance covered after 5 seconds. You proceed on doing that. You keep on working out the areas of these small triangles. Then you keep on finding the areas, and you can fill up this table. Say, after 0 seconds, the distance is 0. After 1 second, the distance covered, the displacement is going to be 1.4. After 2 seconds, the displacement is going to be 5.6. After 3 seconds, it's going to be 12.6. After 4 seconds, it's going to be 22.4 meters. After 5 seconds, it's going to be 35. After 6 seconds, it's going to be 50.4. After 7 seconds, it's going to be 68.6 meters. After 8 seconds, it's going to be 80.9 meters, 89.6 meters per second. After 9 seconds, it's going to be 113.4 meters. After 10 seconds, the distance covered is going to be 140. You get this information, you put it on a graph. On the y-axis, you have your distance or the displacement. On your x-axis, you have the time. So you get to have a picture view of how much distance is being covered as time passes, like that. So more distance gets covered as time passes because the object moves faster and faster and faster. Unfortunately, we do not have a lot of use for a displacement time graph like this one. We also don't have a lot of use for this other one, an acceleration time graph. This acceleration time graph shows us what the acceleration was after each second. That the acceleration was 2.8 after 1 second, it was 2.8 after 2 seconds, it was 2.8 after 3 seconds. So basically here the acceleration is constant. We got this information from the graph already, that the acceleration is 2.8 meters per second when we work out the slope of the velocity time graph. So the most important graph when you're looking at motion is this one, the velocity time graph, because it shows you what the instantaneous velocity is after each and every second. So you know what the velocity of the object is after every second, but you can also find out how fast the object is moving by working out the acceleration from the slope. You can also find out how much distance an object has moved by working out the area under this graph. So all the information about velocity, about if you want to work out the average velocity, you can still do that. This one here, then that one, you add them, then you divide them, you get your average velocity. So everything I've talked about, the distance or the displacement, the speed, the average velocity, the acceleration, can be obtained from this graph. Are we clear?
Yes, sir. Understand.
Yes, we are.
Huh?
Yes, sir.
Yes, it's clear.
Yeah, it can be obtained from this graph. The acceleration here is 2.8 meters per second. It's positive. If the acceleration is positive, it means that, as you can see on this graph, the values of velocity will increase. Okay? If, on the other hand, the acceleration is negative, it means that the values of velocity will reduce, like this. This is a graph, as time passes, of an object whose acceleration is negative. So as time passes, the velocity of that object is reducing until it comes to a stop. This object is slowing down. It's coming to a stop. And if you work out the acceleration here, you find that the acceleration is going to be minus 2.8 meters per second. So the other thing I want to point out is that if the acceleration is positive, it means that the velocity of that object is going to increase. If the acceleration is negative, it means that the velocity of that object is going to reduce. An object moving with positive acceleration moves faster and faster. An object which is slowing down or has got negative acceleration is going to slow down and will come to a stop. These others are just the velocities, the areas under the displacement under this graph. So if you work out the area under this graph, this one, how the velocities will change. So if an object is coming to a stop, then how much distance does it cover, like that? And the last graph talks about just showing that we are working under the assumption that the acceleration is the same, that the acceleration does not change. Okay, in reality, the acceleration actually changes. When you're driving a car, if you find a hump, you have to slow down. Or if there's a zebra crossing, you slow down. Or there's a pothole, you slow down. So the acceleration actually changes. But we are assuming that during the course of our course, the acceleration will always be the same. It will be constant. It will be uniform. And basically, this is what we mean when we talk about something called uniform accelerated motion. The velocity changes, but it changes at the same rate. That allows us to predict what the velocity is going to be after a certain amount of time. We have to end here for today. Are there any questions?
Sir,
Yes.
at the beginning you made some announcements. The network was poor here. Can you repeat them for us?
The announcements I made at the beginning were concerning the quizzes. To say, you are going to have more quizzes coming your way. My estimate is that you're going to have 15 quizzes. You have done one quiz, so meaning that you have 14 more to go. The other thing is that with the quizzes, they are students who want to take an advantage. So they log into your Moodle account. Your fellow student logs into your Moodle account. They try to see the questions so that what they are hoping is that when they log into your account, they don't even try to answer anything. They just try to see. They just click next, 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 next. The problem with that is that you're only allowed to attempt the quiz once. So the moment someone logs into your Moodle account, they attempt the quiz on your behalf, the computer will think it's you because the computer doesn't have eyes. The only thing a computer knows about you is your computer number and your password. The problem is that your computer number, which is what you use to get into Moodle, when we give you the Moodle account first time, is also your password. So if someone knows your computer number, they can get into your Moodle. And that's what happened yesterday. Some students, trying to be clever, they got into other people's accounts. But we're going to follow up that issue and we're going to find you. When we find you, we're going to expel you. And we'll hand you over to the police, apart from expelling you. So if you want to continue this habit of getting into your friends' accounts, by the way, there's a cyber law thing which was when we know your phone. So that phone you used to get into somebody's account to answer on their behalf, that phone is going to bring you down. Okay. So with that, there is this problem where people get into other people's accounts. So what we need you to do is, as soon as possible before the next quiz comes, which is very soon, maybe in the next 1.5 weeks, next Wednesday, that other Wednesday, you might have the next quiz. You need to change the password to your Moodle so that it's not your computer number. Change your password. Then after you change your password, do not share your password with anyone else. Whether it is your bestie, it is your boyfriend, it is your girlfriend, do not share that password with anyone. Because those people will be desperate to see what the quiz questions are, and they're going to use your password. At the end of the day, they will not even answer anything. You will end up getting 0. They will get better marks than you. The other thing is, it doesn't really pay for you to get into someone else's accounts. Because guess what? The only number of questions you're answering is 10 questions. But not everyone is answering the same questions, because we have more than 10 questions which we are giving to people. So the computer will choose 10 random questions for you. For each student, when you log in to take your quiz, the computer chooses 10 random questions which it gives you to answer. So whether you get into someone's account, you're going to see the questions which the computer chose for him. By the time you log into yours, the questions are going to be different. So it's really a pointless exercise in you trying to get into your friend's account. You will just get expelled and get arrested at the end of the day. It won't pay. Your career as a university student will come to an end very shortly. If this is a career of hacking into other people's accounts, that's what you want to do. Okay? Because we give the computer many questions, so it chooses only 10 questions for you. Are we clear? The other thing we're going to expel you for, is screenshotting the questions. Because you're using a mobile phone, then you screenshot these questions, then you send them to your friends. Those friends you're sending them to, as you screenshot your questions, will get better marks. If one of you comes and reports, say, this guy screenshotted, this is his phone number, this is his name, he screenshotted and was sending these screenshots. I think it happened yesterday. So if someone reports, we're just looking for a volunteer to report. Say, here is the evidence that this person was screenshotting and was distributing quiz questions to other students. We are going to expel you from the university. So do not try to screenshot. Try to be helpful, because what you are creating is a leakage. Do not screenshot quiz questions. It doesn't matter when the evidence comes. It might come in November, or someone might send us proof. Say, here is proof that so and so and so was screenshotting questions and sending them to on WhatsApp. Whenever we receive the evidence, we're going to act on that evidence, and you will get expelled from the university. Are we clear?
Yes, sir.
So that's what you're supposed to do. Change your password. Do not try to enter into other people's accounts. That would get you expelled. Do not screenshot questions and distribute them. That would get you expelled from the university. Are we clear? The next quiz, by my estimate, is not next Wednesday, but that other Wednesday. After next week, then that other Wednesday, you should be expecting a quiz. After we have done this uniform accelerated motion stuff, there should be a quiz on that. So after every topic, you're going to have a quiz. After every topic, we'll give you a quiz. That is how we're going to keep you on your toes, and also at the same time, that is how we'll make sure that even as you go home, you stay at home, you attend class, and you study. Because your quizzes are going to be online. Your tests, test 1 and test 2, are going to be online. So the university computers will be marking, and automatically, we like computers because, as you can see, you already have your quiz results very fast and you're not biased. The computer marks very fast. So that's a good thing. So your quizzes will be online. Your two tests are going to be online. The only thing you're going to write physically is when you come at the end of the year to write your exams, your physical exams, your final exams. Are we clear?
Yes, sir.
We find proof that you have been cheating, you have been screenshotting, you have been getting in other people's accounts. You will get expelled and you'll get arrested. So please, do not, by the time you come to us begging us for forgiveness, we will not forgive you. We can assure you that much. We are not in the habit of forgiving criminals masquerading as students. So your criminal career, leave it aside. Okay? We don't want it here. Unless there are any questions, I'll stop sharing.
Yes, sir.
Yes?
What did you say about the percentage allocation? The quiz, it carries how many percent? And
The quizzes, each quiz you write is 1%. Each quiz is 1%. So all 15 quizzes add up to 15%. Are we clear? All the 15 quizzes, they add up to 15%. The labs you have been doing, they are 15%. The two tests, each test is 10%, 10%. So you're going to write two tests. So altogether, your quizzes, your labs, quizzes 15%, labs 15%, test 1 10%, test 2 10%, altogether they add up to 50%. So by the time you come to write your final exam, you already know whether you have passed or not, because passing is like 40%. Then you write your final exam, that is also going to be, the final exam is just 50%. Is that clear?
Yes, sir.
Yeah, so let's continue working very hard. Let's continue attending class, and the labs, I think the labs are done, so that 15% is done. So people mark your labs. In the meantime, the computer is going to mark your quizzes and tests. We are going to mark your exam at the end of the day, at the end of the year. Okay, so we'll stop here. See you tomorrow when we start looking at equations of uniformly accelerated motion. We have seen how to do the motion stuff using graphs. So tomorrow we're going to come up with equations which we can use to do the same thing. Okay, I will stop here.